So let's look now at exponential and logarithmic equations. And this is going to help us solve logarithmic and exponential equations. What we have to remember is we're going to use all the rules for exponents and the laws of logarithms. And these laws of logarithms have been established, but now we can use them to solve equations. And remember, anytime we have an equation, we have an equal sign. So the solution is going to equal something. We're often going to find x equals some value, some unknown solution for a variable. But the thing we always have to remember with logarithms is there's a certain domain of the function. There's restrictions on the base and the argument. The base must be greater than 0 and not equal to 1. And remember, the argument must be positive. And we're going to keep that in mind as we solve these equations because our solutions could potentially be extraneous, have extra solutions. So let's look at the steps for solving a logarithmic equation. And it's pretty straightforward step by step. First thing we do is if our constant exists, then what we must do is bring all the logs to one side and put the constant on the other side. So we're going to move logarithms around using algebra to get a constant to one side and the log to the other side. If there's no constant, or if that's done, then we take our logarithm and combine it into a single log. We want each side to be down to a single logarithm with a common base. From there, we can do some conversion. We either want to convert from logarithmic to exponential or vice versa, or we're going to use this rule quite a bit. Log base b of some argument equals log base b, same base, of another argument. That allows us to set the arguments equal to one another, and then we can solve the argument values, solve for the unknown in that case. Once we've done whatever we need to get an equation with just the variable, then we use all our techniques from algebra to solve for the unknown. And the last step, we must check for the extraneous solutions. We must check that we're in the domain of every logarithm in the original equation. So let's put this together in an equation, like this one. Solve for x in this equation. And let's bring in our rules. And we're going to use these rules to solve for this logarithm. First thing, if a constant exists, bring all the logs to one side. Well, we definitely need to use that rule because we have this constant 1 that exists. So we're going to take the logarithms and move them to one side. Just doing algebra here, that'll give us log base 9 of x minus 5. Moving that logarithm to the other side makes it positive. Log base 9 of x plus 3. And that's going to equal just that constant term. So there we go. All the logs are on one side. Once they're all on one side, now we want to combine into a single logarithm using our established rules for logarithms. Well, they both have a base 9, which means this sum can turn into a product of the arguments. Just multiply them together. And that gets us down to a single logarithm. Log base 9 of x minus 5 times x plus 3 is equal to 1. Well, now we can take and convert from logarithmic form to exponential form. Taking it out of log base 9 and write it as an exponent base 9, and it would be 9 to the 1 is x minus 5, x plus 3. And all that work now takes us out of the logarithmic world and into an equation that we can solve because it's just a quadratic. This will give us x squared plus 3x minus 5x minus 15. And remember, solving for a quadratic, we need to bring everything to the same side, combine our like terms, and we'll get x squared minus 2x minus 24. And now we have to use all our rules for solving a quadratic. This one's nice because it just factors into x minus 6 and x plus 4, and that's all equal to 0. And that tells us from the quadratic we have two solutions of x minus 4 and x equals 6. Now that's the solution from the quadratic, but that may not be the solution for the logarithmic equation because we must check for extraneous roots. And how do we check for extraneous roots? Well, look back to the original equation. Here's our two arguments. We must consider that those arguments must be positive. So the restrictions on x, the first argument, x must be greater than 5. Any number smaller than 5 will give us a negative value, not allowed. The other one, x must be greater than negative 3. Again, if we put a number smaller than negative 3 in there, we would get 0 in the argument, not allowed. So we have to compare our restrictions on our domain to our final solutions, and it's pretty easy to see there. Negative 4 is not in the domain of the original logarithm, so the only solution is x equals 6. And we're going to do a number of examples using logarithmic equations and using these 4 steps. But it's very important that we don't forget to check for extraneous roots, solutions that wouldn't meet the domain, and throw those away if needed. And we're going to do a number of examples like this in class.